If you want to understand how much have we learned in peer-to-peer protocol performance optimization and modeling, and how can we determine if we are clear about the user behavior, we solved some problems which are specific to the peer-to-peer operation and a simple problem that relates to user activity monitoring. Let's look at the peer-to-peer protocols operations first. Suppose that in a configuration, say circular DHT, there are multiple peers. One of them, peer 3, learns that peer 5 has left. Now, if peer 3 had to determine its update status, how will it update its successor state information? Because peer 5 is the successor to peer 3. The first option is it asks its predecessor, peer 4. It asks one of its successors, peer 8. It asks peer 2. And if you do not agree with any option, then you can choose D. You need to consider one reality, that is, 3 for sure is the immediate neighbor to peer 4. It is not the immediate neighbor of peer 8, and it is the immediate neighbor of peer 2. Now you have to make a wise choice which peer has to be updated. Another important problem that deals with the understanding of user performance and user activity is to know for how much time does the user remain active, so we can determine from that how much effective load is posed to the network by that particular user. Let's look at the expression. Here you see that there is 1 megabits per second link. It could be T1 link, that is 1.544 megabits per second for simplicity. If each user generates 200 kilobits per second of activity and is active for 20% of the time, then what is the probability that if there are, say, 100 users, more than 5 users would be active? Now, if you look at it critically, it is a binomial distribution problem because we are interested in the users either being active or not active.